Last video, I explained to you guys what the difference is between a molecular and an empirical formula. But this time I wanted to give you an actual problem that asks you to find the empirical formula, that asks you to find the molecular formula, so that way you will actually be able to calculate it and see and put it into practice. But before I get into this video, I just wanted to say, please follow me here and on YouTube. I know like a lot of you guys are liking and saving, which is amazing, and I feel great about it, but I really want you guys to follow as well. And also please go to the top of this page, click YouTube and click subscribe, and help your girl out, because it takes time to create this content. And on YouTube, I don't know if there was a confusion, but on the page there's playlists, and in the playlist you have a bunch of folders. So chemistry, organic chemistry, biology, anatomy, physiology, biochemistry, etc. So if you're interested, go check those out. I have all of my videos related to that subject in there, so it's going to make your studying much more efficient. I'm a pre-med student, and so I have a 4.0. So I've been through this whole process, and I really want to help you guys and give you the tricks that I used, and you hopefully can implement it in your studying and also do well and succeed. So let's get into this video. So it says find the empirical formula of a compound that has 30.1% nitrogen and 69.9% oxygen. So what are you going to do? They give you a percent mass. So treat it like the percentage is actually the amount of grams that you have of that. So for the first one, I have 30.1 grams of nitrogen. And if you go to the periodic table, then you see that it has 14.007 grams of nitrogen and 1 mole of nitrogen. And when I calculate that, I end up with like 2.15 moles of nitrogen. Again, this will cancel with this, and so I know I'm left with the moles. And then I have to do the same for oxygen. So for oxygen, I have 69.9 grams of oxygen, and I have 15.999 grams of oxygen and 1 mole of oxygen. So again, it's going to be 69.9 divided by 15.999, and I get about 4.369, well, so around 4.337. Don't round. I'm rounding here, but really, honestly, you can't round until the end because you can have something called rounding error. So make sure that when you're actually doing this division and stuff, that you don't round, because that can influence your final answer. So right now, what I want you to do is to actually put the 2.148925537 or whatever, and you divide that by this. I'm going to write 2.15, but again, write by the actual number. This is going to give you 1 approximately. And then if I divide this number, the 4.369023 whatever, divided by the 2.1489 whatever, then you're going to find out that it's 2.033. So what this is telling you, this is pretty much like the whole number. So you know that you have NO2, and that is going to be your part A. This is the empirical formula. We cannot reduce it anymore, so that is definitely it. But what about part B? So we know that again that this is the empirical formula. Well, for the molar, it says for part B, if the molar mass is 138 grams, what is the molecular formula? So what can we do? So let's first take this, because we know that this is actually, like we said in the last video, the ratio, right? And it tells you what the proportions are for, like, you have 1 nitrogen for every 2 oxygens. So let's find out what the actual mass is. So if we said that nitrogen is 14.007 and oxygen is 15.999 plus again 15.999, then this is going to be about 46 grams. And again, what I did is I said nitrogen is 14 plus 2 times, because there's 2 oxygens, 16, and you will get this number, 46 grams. So what they told us in this problem is that we have 138 grams. So let's divide by this number, and it'll tell you the amount of times that you have to multiply the empirical formula by to get the molar formula. So again, it will be 138 divided by 46, and that's 3. So we know that NO2 is going to be multiplied by 3, and that's going to give the actual molecular formula. So it's going to be N3O6, and that would actually be, again, the molecular formula. So what did we do? Just to recap. In part A, we found the moles. We divided by the lowest number of moles to find the ratio. We found out that the ratio was NO2. The empirical formula was NO2, so there's 1 nitrogen for every 2 oxygens. We found the molar mass of the compound was 46 grams. And they said that a compound that we actually have is 138 grams. So I divided what we have by the empirical formula to know what the molecular formula would be. We found that 138 divided by 46 is 3. So that means we have to multiply the empirical formula by 3 to get our actual molecular formula, which is N3O6. Again, if you enjoyed this video, please follow here and on YouTube, and please share, like, comment, let me know if there's any other problems or videos that you want me to make. And thanks again for watching.